Alright, so today we are going to talk about binary logic. Okay, and binary logic shows up everywhere. It's used in programming, and it's used for our PLCs. And understanding binary logic is necessary so that we can understand Boolean algebra. Okay, but today we're going to just talk about some basic binary logic. Now, binary logic is based upon the fact that a value or a variable can only be 0 or 1. Can only be 0 or 1. And we have some operators in binary logic. And these operators are the AND operator. Okay? So if you have two variables A and B, you can do A, this little dot here, sometimes people omit it. This would be A and B. Okay? So if it's 1 and 1, it would be the same as multiplying, 1 times 1 is 1. If A is 1 and B is 1, okay? If A is 0 and B is 1, then you'd get 0. If either one of these is 1, you'd get, if either one of these is 1, you would get, if either one of these is 0, then you get a 0. Okay? So this is the AND operator. We have the OR operator, which says, is one of these true? So the AND operator basically says, are both of these true? Okay? The OR operator says, is either of these true? Okay? Is one or the other true? And notice we're always talking about one or the other, or a binary state. We're testing between two things. Okay? So the OR would be if we have an A and we have a plus sign, that's our OR operator. And we have A or B, okay, equals something. So if, say A is 1 and B is 0, we'd get 1, because 1 or 0 is 1. It means one of them is true. So the first one or the second one is one of them true. And if we had a 1 and a 1, we'd get a 1. And we'll expound on this a little bit later. The results of these Boolean operations, or this binary logic, can be summarized in what's called a truth table. Okay, and we'll talk about that. So we have the variable itself, which can take on the values of 0 or 1, and we have operators such as AND and OR, and we have another operator that is called the we have the exclusive OR, excuse me, we have the exclusive OR, okay, and that's called the EXOR. Okay, and we want to know if A exclusive OR B is true. And in this case, we want to know if exclusively A is true or B is true. Okay, up here in the OR case, we just saw if both of them are true, we still get a true. And in this case, if A and B are true, then we would get a 0, because it says, is A true exclusively or B true? And basically, that exclusive OR means that we want A to exclusively be 1 and B to be 0, or we want A to exclusively be 0 and B to be 1. Okay, so the only way we get a 1, okay, that would be a 0, is if we had exclusively A was true or B was true. Okay, we also have a not operator, and the not operator just is signified with a line over the variable. Okay, and if a is 1, we want this to be 0. We want it to not be what a is. If a is 0, we want it to be 1 because we do not want it to be what a is. So not is a way of changing the state of a variable. Okay, and a state would be in the state of 1 or the state of 0. So it changes the state to the opposite state. Okay, so these operations that we just defined are not a comprehensive list, but can be used to derive other operations such as a NOR, which is like a not or, and we have a NAND, which is like a not and those tables can also be derived from what we have